Welcome back, everyone. Would you all like to take your seats, please? Can we encourage you all to... We feel encouragement is better.
Outside will be better. You can't do any remote participation outside?
No. There's no Wi-Fi. Can we all take our seats so we can start? Okay. Next up is Marco from Arista, who's going to talk about Arista's 400 gig roadmap. And if it's the talk I've seen elsewhere, it's a good one. So enjoy.
All right, thank you. Can you hear me? Is my mic on? You can hear me?
You're on.
All right. All right. So, slight correction. I'm not talking about Arista's roadmap. I'm talking about 400 gig roadmap. This is two different things, perhaps. But anyway, so my name is Markki Rantanen. I work for Arista, based here in Finland. And I could start by saying that unlike the others presenting here today, they speak, like Antti was speaking about, hands-on experience on doing something. And this is some doing automation to the network, for instance, and or routing policies, etc. 400 gig. Hands up, who has experience on 400 gig? Well, 400 gig interfaces, so pretty low number of hands. So, anyways, I have zero experience on 400 gig interfaces. None of my customers are using it. So, but anyways, this is a from a vendor's perspective, how things are evolving in the 100 gig and 400 gig markets, etc., and what is needed, what changes, etc. So, the reason why networks are built with 400 gig or should be built in 400 gig interfaces is that the bandwidth increases and more bandwidth is and capacity is needed for the networks, and as always, there's a certain trend, and the older technology stays a little bit starts showing a little bit declining curves, and the new technologies start showing somewhat phased out forecast in how they are ramping up with the deployment rates, etc. But this is no different from going from 10 gig to 40 gigs and 40 gig to 100 gig, etc. And the old truth is always the same, that the only and the simplest way to get faster is to go faster. And this way, go faster means that getting into 400 gigs. 400 gig platform started to be announced by multiple vendors end of last year, or maybe somewhat early 2018 summer, etc. Anyways, the deployment is somehow related to the availability of the optics as well, and the standardization of the optics too. Of course, then the real need, who really needs 400 gig interfaces on a single port. Typically, those are the biggest cloud players as of today. But then again, let's not think that it doesn't concern us being here in a remote and small country. I'm pretty sure that as any other technology passed in history, this will show up in our networks too in maybe a few years. But anyways, here you can see the forecasted ramping up of different technologies and how they have actually realized and how this will happen in next few years. So how do we get there? How did we get from 1 gig and 10 gig interfaces to 100 gig and 40 gig interface speeds? So all these ASICs, either in the NICs on the servers or on the ASICs on the switches or routers, they have a concept called lane. And a lane is like a highway lane, and if you have multiple parallel lanes and you have certain speed on each lane, you get your aggregated bandwidth or throughput. And same in here, so everybody is aware of that 100 gig interface, for instance, is 4 by 25 gig lane, and those are in ASIC terminology we call them Serdes, which is serialization, deserialization technology. So it's the question of number of lanes available for certain speed and throughput technology on Ethernet technology, and the speed of individual lanes. So here we can see what kind of speeds we are actually using and been using in slower speeds like 10 gig interfaces, how that evolved into 40 gig interfaces, and how will that evolve then, or has now evolved to 400 gig interfaces, and then what is the forecast for 800 gig interfaces. So basically it's the typical switches have evolved from 10 gig SerDEs to 25 gig SerDEs, and then to 50 gig SerDEs, and of course you have 100 gig SerDEs as well. The actual number is, by the way, 28 gig, 56 gig, and 112 gig on the electrical connector level. But mapping to equal or even number of 100 gig technologies. So this is pretty much the mapping between different SerDEs to the time scale, and also on the switch interfaces versus the server interfaces as well. So there you get somewhat good understanding how that happens. And how this 400 gig now has happened is that industry increased the bandwidth of individual SerDEs from 25 gig to 50 gig. From switch ASIC or router ASIC perspective, here's an example that when 100 gig interfaces started to appear, the first generation of the ASICs, they actually used 10 by 10 gig SerDEs. And in order to get into that optic QSFP-28 optic connector, the AUI on that QSFP is using 4 by 25 gig NRZ modulation, and then you need something called a gearbox between the ASIC and the actual connector connecting to the SFP. Further along the time, the switch ASICs, they actually evolve as well. So basically the SerDEs jump from 10 gig to 25 gig. So this maps exactly to the SerDEs or the connectors on the QSFP. No need for gearboxes on the switch. And then when getting now, or since last year, end of last year, the switch ASICs with 50 gig SerDEs, how they map into 100 gig interfaces or 400 gig interfaces. So basically there again you need a gearbox as if you're using a 100 gig QSFP ASICs. So now from 50 gig down to 25 gig in order to have compatibility between those ASICs. So those are the blue boxes here are inside a switch or device. So but there are gearboxes on QSFPs as well, depending on what type of ports they are connected to and what is their modulation from the switch ASIC. Okay, so I mentioned modulation briefly. So if we take back here, we see that we are talking about, in this 100 gig interface, we are talking about 25 gig NRZ modulation, and with 400 gig, which is today's topic, we are talking about PAM-4 modulation. So the difference is there is that, which is clearly seen in this one, the NRZ 25 gig or 28 gig is the actual speed of the lane. In this modulation, it is 1-bit encoding in NRZ. So this is the simplest way to get a 25 gig, and it's pretty much the maximum that you get out of it. So in order to get faster speeds, a double density and bitwise, so 2 bits equaling 4 different values. So you are using 4 different voltage values in order to describe the digital states of that 2-bit encoding. And here's the eye diagram compared between the NRZ and PAM-4 modulation. So just for your understanding that these are the modulations between 100 gig interfaces and 400 gig interfaces. This is an interesting slide showing well, it talks about legacy 100 gig interfaces, like we have abandoned that technology already, like then. So I have lots of customers who don't need that speed in the first place. But anyway, so legacy or current. So if you take that ASIC, what we are using today in current technology, is that the switch ASIC has 4 by 25 gig NRZ modulation on the electrical side. And then you have the QSFP-28 optic with today commonly used optic types, short range, long range, and different other modulations. There we do one-to-one mapping from electrical to optical modulation at 25 gig NRZ. So this means that there's no gearbox, it's just the timing and generating optical signal one-to-one mapping from the electrical. This is the, and if you have been wondering what is the number 4 in typical optics, so LR4 or SR4, it means that it has 4 wavelengths and they are on that same, if you have an SC connector using 2 fibers down and up, then all those 4 wavelengths are on that same physical fiber. So there comes the number 4 in the optic type. So then going to 400 gig, so as said, the lane speed and the number of lanes is increasing. So we are doubling the number of lanes. So it used to have 4, and 4 by 25 is 100, and now we have 8 lanes, each of them 50 gig. So in 8 by 50 is 400, and there you get different optics again. But in this case, because it's 400 gig optic, the standard uses 4 wavelengths. So it means that in PAM-4 modulation, each of the optical wavelengths is now, or the modulations on that wavelength is 100 gig. So in this case, we need to have a gearbox from 850 gig Serdes to 4 different PAM-4 modulated wavelengths on the optical side. So why not use 8 there? Maybe 8 lasers is cheap, more difficult to fit into the same optics, and there are economical reasons as well why 4 is being used. There again, now the optic type is not QSFP, just I will go into the form factors of different optics, so this one you can pay attention a little bit to this. So in 400 gig you have different optic form factors available. This is just showing 2, but there are more. Then this is pretty neat. You get 4 wavelengths to get 400 gig, and each of them is 100 gig. So then you get an idea, okay, I can break this down to 4 different individual 100 gig interfaces. Yes, you can do it, but you can't connect it to legacy or current QSFP modules because they are using 4 by 25 gig NRZ modulation, so the modulations do not match. So you have 4 by 25 and one is 1 by 100, so it doesn't match. So what you then need is a new optic type which goes into this current generation switch board, having those 4 by 25 gig NRZs, and then a gearbox on the optics that is changing or maxing up to or down to 1 PAM-4 modulated 100 gig signal. So this this optic type here, DR or FR optic, which is coming as a new optic type, which is compatible with 100 gig, is broken out from the 400 gig interface. And then again, the same modulation, 100 gig PAM-4 modulation is used in 800 gig interfaces. So, and how is this then done on the switch ASIC side is that we are not anymore using the same Serdes, so we are then going from 50 gig Serdes used today, 8 by 50, in order to get 400 gig out of the switch port, to 8 by 100 gig Serdes from the ASIC, and their one-to-one mapping into PAM-4 modulated optical wavelengths. So quick overview how the different available ASICs available from different vendors have evolved in time. This means that there are optics that can do all this capacity and the number of interfaces, like 12.8 terabits on single chip. So there are different approaches. So basically, looking into this, what kind of ASICs are available and how many ports you can get out of it, understanding the Serdes are parallel electrical wires, how many of those need to be there in order to get, let's say, 32 400 gig ports in one rack unit size or attached into one single ASIC. So that's one thing, that there are available chips that have this capacity, and then there are other chips that don't have the capacity in single chip, but you can use multiple chips. Maybe these chips, devices built out of from multiple chips, they have more complex capabilities down at the ASIC level. Then getting the same capacity out of it means that you need to use multiple chips. So looking at those devices, then what they could be is that maybe a router doing some routing specific things is based on these type of ASICs, and a data center switch is based on a different type of ASICs, being much more lower latency, less power hungry, based on one silicon design, based on multiple ASIC design on perhaps a larger chassis type of modular devices, etc. But the use cases are different, and the different ASICs are available for these use cases. But anyways, still allowing to use multiple 400 gig interfaces. Form factors, it's not so easy. Okay, so CFP8, OSFP, QSFP-DD. Those are the most common things that are available. So first of all, there are those. They are all different sizes. So CFP is the largest one. So it is quite clear that you are not able to make a data center switch out of CFP ASICs. I mean optics. The reason is that you only can get a low number of optics on those by using these optics. Then you have QSFP-DD and OSFP. I will tell more about them. They are commonly seen on devices that are used in the data center, but maybe CFPs are used in the long reach ZR optics on router ports, for instance, where perhaps you don't need high density 400 gig ports, maybe just 2 of them, and then additional 100 gig interfaces on the same line card, etc. Here are some facts from them. They have all of them. They have different Serdes capabilities. This has 16 by 28 gig Serdes, up to on the optical side 8 by 50 gig. Even though the others, the LR and the FR and DR optics, they were using 100 gig PAM-4 modulation. This one is using 50 gig modulation on the optic side. So there are different use cases. The forecast for this is not in a data center. It will have longer reach optics, easier to be built on this one because it's a larger form factor. It's easier to cool. It tolerates higher power consumption, and then will not potentially be an issue. Then the others, QSFP-DD. QSFP is the same form factor. So I mean the QSFP-28, which is the 100 gig QSFP, and then this QSFP-DD for 400 gig. They are the same form factor. This one is using 8 by 50 gig Serdes or 4 by 100 gig Serdes to the switch, and then 4 by 100 gig PAM-4 modulated on the optical side. Its future is for the regular LR4, DR4, FR4 type of optics, but its future for the 800 gig is challenging because it only has easy to implement 4 by 100 gig Serdes. It's difficult to implement 800 gig Serdes on this form factor. Size is the problem, and then the other problem is that you may not be able to use long reach lasers on this form factor because then again maximum rated power consumption for this is 15 watts, 12 watts, and ZR optics might be a challenge. Then there's another SFP. Later today, try to say OSFP 10 times very quickly. I bet some of you will say OSPF, and which is a different thing, of course. But anyway, so OSFP, which is an octal SFP, which means that it uses 8. It can use 8 100 gig SerDes as well. So it supports for 400 gig today, and it is forward compatible for 800 gig Ethernet deployments. Due to its larger in size, it's easier to fit those 8 by 100 gig SerDes on the electrical side to this optic type. And then because it is larger, it has better power and cooling option, then it can use the ZR optics as well. QSFP-DD is compatible with the QSFP-28 port, so you can take your existing QSFP-28 100 gig SFP and plug it into the 400 gig QSFP-DD port. So those are compatible. If you have a switch that has OSFP ports, then you need to have a passive adapter adapting the QSFP-28 into the OSFP slot. It's mechanical adapter and it's electrically compatible. So just quickly comparing this to the time, I will not go through them. Is the OSFP is superior on terms of the power and heat tolerance. Different optic types, it gets hairy. So there's a lot of things, but basically the optics, what you're typically using in data center today with the lower speeds, can be used up to 2 kilometers today, mostly with single mode fiber. And very short range SR8 can be used in multi-mode in existing data centers. Beyond 2 kilometers, you could go with LR4 optics, but it's not standardized yet completely. LR8 optic is available as well before end of this year, and maybe early next year LR4 optic will be available for longer than 2 kilometer range of fibers. But anyways, here's a nice overview what kind of optic types there are and physical connectors, etc. This is running out of battery or something, or this is not the last slide.
Can we get the next slide, please?
Okay, now it's here. So basically, this goes hand in hand, the development of the optics and the modulations and mapping to the SerDes available on the switch ASICs or router ASICs. And this one is also showing you quite nicely what kind of modulations you could have in different optics. And basically, all of these are available today except the LR4 and LR8 and the ZR. And one thing to note that there is a intention in the industry that the ZR optic will be interoperable between vendors. So that's their goal. Today, it's not. And with 100 gig, but in 400 gig, there's a high pressure from cloud titans. Let's not mention the names, but anyways, cloud titans are certain companies. So the pressure is coming from them. There again, what kind of optic types you're using, how many fibers you need, either 2 fibers or 8 fibers, and so on. And also this is showing from optic type as well, what is their power usage, etc. Going a little bit further, I will jump this over and show you once I could jump now.
Can we get the next slide, please?
Now it works. So also it's not the market for 400 gig Ethernet is not only just the 400 gig availability, but just like 100 gig interfaces are mostly people are using the breakout cables to use lower speeds as well. With 400 gig is the same thing. So you basically can split this out to all right. So the timeout is really it's actual timeout. So anyway, so showing you how you can actually use the breakout cables and what kind of optics types you need to have on each side. And this is not for us. We didn't make this naming. So XDR, this is the extended reach of DR optic. And if you take that out of the 100 gig interface, it is FR optic. So nobody knows why. And anyways, these are the naming conventions, and they're made in IEEE. And funny enough, but anyways, so these are the options basically what you have in breaking out to 100 gig interfaces. And then there is a option for 200 gig mode of the port that you can get only 200 gig keys out of one 400 gig port, etc. Depending on the fiber type that you have, you must choose something, and that's why it is only two optics, etc. So and then glimpse of the future. It means that you need to go into the 100 gig Serdes in order to get into 100 gig PAM-4 modulation, and mostly it is 8 wavelengths. Of course, there are a few 4 wavelengths versions as well, but this is using then those ports in 400 gig mode, so 2 times 400 gig modes, etc. But anyways, so my time is running out in 10 seconds. But anyways, so quickly summarizing, all the familiar optic types and reaches should be available both in 400 gig and 800 gig technologies, and yet anything beyond 2 kilometers is in the future, but not too far. So, any questions? I don't have any hands-on experience on 400 gig. I already stated that.
Okay.
Node Internet Exchange.
Is the mic working for Kai?
Hello?
Yep, it does. I think so, at least. Anyway, I got a question about the 100 gig PAM-4 that you said that you can split into from the 400 gigs.
Yes.
How far is the reach on that, and how far away is that?
It's using today FR optic. I think that's 2 kilometers only. Currently, I think. I have a cheat sheet where we can take a look, and I have some which I haven't shown here. So all these things, how they are evolving, and a little bit in the roadmap as well. So it is FR optic that you can use in there, and DR optic, and when you're using the PAM-4 100 gig modulation. But I think those are 2 kilometers. And DR is actually 500 meters, and FR is 2 kilometers. Yeah.
Has there been any talk? I'm Alexi, everyone. From Czechs. So has there been any talk about bidirectional optics at these speeds? There has.
There has been.
That's exciting.
That is in a. I have some material on that one too. Bidi is coming too.
So you will be here all evening. Can we get a sneak peek on the terrace or something?
Yeah, I keep my laptop closed. So
yeah.
Anyway, yeah, sure. Why not? Yeah. So.
Please do feel free to come up and are you queuing? No. Okay.
All right.
Okay. Any more questions? Okay. Thank you very much.
Thank you, guys.
Very interesting.